Our next data set is much longer. Here we have n equals 17 measurements. We still need to start the same way by putting them in order. So I see that 1 is the smallest number I have, and it happens a bunch of times. I'm going to count how many. 1, 2, 3, 4, 5 ones. So I'm going to start off listing 1, 2, 3, 4, 5 ones. Then I see 1, 2 twos, 1, 2. I see 1, 2, 3, 4 threes, 1, 2, 3, 4. Then I see 1, 2 fours, 1, 2. Then I see 5, 5, 5, 5. Then I only see 1, 6, and I only see 1, 7. I want to double check that I have 17 measurements that I'm supposed to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So yes, I do now have them in correct ascending order. When I now am asked to calculate the 5 number summary, 2 of these are super easy. The minimum is the first number in my list, 1. The maximum is the last number in my list, 7. So I can always fill in the minimum and maximum as the first and last numbers in my list. When I go to calculate the median, I'm going to do my position function. Here I have 17, so n plus 1 is going to be 17 plus 1. Divide that by 2, gives me 18 divided by 2, which gives me the 9th position for the median. If I count over 1, 2, 3, 4, 5, 6, 7, 8, 9, this is my median, so I'm going to record my median as 3. If I now want to find the first quartile, Q1 position, I'm going to take 0.25 times n plus 1, in this case 17 plus 1. That gives me 0.25 times 18. If I put that in my calculator should tell me that it's 4.5. That tells me that I want to start at the 4th data point. 1, 2, 3, 4. So the 4th data point is 1. I'm going to add to that the 0.5 that's left over times the 5th data point, 1, minus the 4th data point, 1. In this case, since the next data point was the same as where we started, this all goes to 0, and I just get an answer of 1 for Q1. If instead it had been, say, here, and this was the 4th and this was the 5th, then it would be 2 minus 1, it would be 0.5 times that. So, to be clear, the way that I'm doing this position function is I start at whatever's in front of the decimal. That number begins my quartile. Then I add to that whatever fraction is left after the decimal times the next number in sequence minus the number where I'm starting. Same general idea for Q3. In this case, it's going to be 0.75 times 18. When I put that in my calculator, 0.75 times 18 should give me 13.5. What that tells me is that I start at the 13th number and I go 0.5 towards the 14th number. We know 3 was our median or 9th number, so 10th, 11th, 12th, 13th number. I start at that 4 that is my 13th number. I add to it 0.5 times the next number in sequence, 5, minus the number where I am, 4. 5 minus 4 is 1, so this becomes 4 plus 0.5, or 4.5. We're going to put in for Q3, 4.5. Now that I have my 5 number summary, I can calculate my IQR as Q3 minus Q1. So 4.5 minus 1. That's how I get 3.5 as my IQR. The other thing I can do with the 5-number summary is I can create a box plot. I start with a reasonable key. Since I only go 1 to 7, I'm going to go from 0 to 8 by 2s. So 0, 2, 4, 6, 8. Whenever you're making a scale like this, make sure it's a consistent scale with the same distance between each point. Definitely don't just mark the 5-number summary points on your scale. You want your box plot to fit to your scale, not your scale to fit to your box plot. Once I have my scale laid out, I then look at these 3 key numbers in the middle, Q1, median, and Q3. The median would be here at 3. Q3 would be about there, closer to 4 than it is to 6. And U1 would be over here at 1. After making those 3 lines, what I want to do is connect them as a box. When I'm looking at a box plot, this box represents the middle 50% of the data, with that line in the middle of the box representing the median. I now want to put in the minimum. In this case, since the minimum is the same as Q1, I don't really need to draw anything new in. If I want to kind of darken that side of the box, that makes sense. But when I go to the maximum, I do have something new to put in. I have this line that's between 6 and 8 at 7. What I want to do is then connect that back to my box. When I'm asked to identify any outliers, this 7 is really my candidate. It does look like it's somewhat far from the box, but there's actually a mathematical way to find whether something is an outlier or not. If from this quartile, it's further away than 1.5 interquartile ranges, that's the definition of what makes something an outlier. In general, for this class, I do not need you to know that definition. Look and see, and if something looks like it's very far from the box, call it an outlier. But in general, this would not fit the rule. My IQR is 3.5. This endpoint is 4.5. From 4.5 to 7 is less than 1 IQR. So in this case, there would be no outliers. If I took the same data set and I threw in a number like 17 here, 17 would be far away from the rest of them, and it would be considered an outlier. But again, for the purposes of this class, I don't need you to do the mathematical formula for outliers. Just kind of look at it and say that one looks really far away from the data.